That's better. Alright, what's up, everybody? We're gonna do some math videos. You like the new hoodie? Check that out. That look familiar? Anyway, so yeah, that's what we're gonna do. So let's get ready. So here's the goal: 6 algebra 2 problems. I'm gonna be in real good shape if I can get through 6 algebra 2 problems. So new note. All right, screenshot. All right, let's do it. So we're solving more inequalities. And how do you solve inequalities? You solve them just like an equation. So just like an equation, of course you don't have to do this, but we usually like to keep the x positive. So I'm just going to add the 2x to the other side. We're going to subtract 5 from both sides. So we're going to get that negative 2 is less than 2x. And we'll divide by 2 and get that negative 1 is less than x. Or, if you want, flip it around, x is bigger than negative 1. And that's really all there is to it. So, just for fun, let's solve it like another way, just to show how it would work. So what if instead of adding the 2x to the other side, we just subtracted the 3 to the other side? We'd get negative 2x is less than 2. And then we're trying to get x by itself, so we got to divide by a negative 2. And remember, you're dividing by a negative, so you got to flip the sign around. And so we get the same, that x is greater than negative 1. And then the last thing might be nice, write an interval notation. So we're saying x can be anything from negative 1 to infinity. But it can never actually be either of those things, so that's why we got parentheses. All right, good stuff, good stuff. So let's toss her. That's one down. Another one, pretty much the same. So here's another inequality we're going to solve. It's a little longer, but it's going to be the same idea. We're just going to get the x together and get the numbers together. So subtract 2x from both sides, subtract 7 from both sides, get that 2x is greater than or equal to negative 10. Divide both sides by 2, x is greater than or equal to negative 5. And there we go, that's our answer. If we want to write it in interval notation, we'll use a bracket this time because it is allowed to be negative 5. Anything from negative 5 to infinity. All right, good stuff, good stuff. So let's toss it. Come over here. Oh, yeah. So now we're solving this inequality. And I just love writing inequalities like this, because I think it just really shows what's actually happening. That the 3x minus 2 is between the negative 5 and the 1. And honestly, you solve it no differently. The only difference is there's 3 sides of the equation now. So when we still try to get x by itself, but like when we add 2, we're going to have to do it to all the sides of the equation to get us that negative 3 is less than 3x, which is less than 3. Or 3x is in between negative 3 and 3. And then we just divide all of the sides by 3. And we see that x is in between negative 1 and 1. and the last thing is interval notation, and we just write that from -1 to 1. And we use parentheses because x is not allowed to actually equal 1 or -1. Wow, these are short videos. That's good though, right? So let me try this. Alright, let's do a 10-minute game. Let's see how it's going to go. Okay, so we're going to try it. We're going to Queen's Gambit. I'm going to go ahead and take that side. I don't know what the best move is going to be. So yeah, he's still kind of coming for that to be ready. Let's get that backed up. So then when we do that, it's protected. It's beautiful. And then we can bring the bishop in. That's beautiful. So let's see. That's not sufficiently protected now. But that could just be a trade. So that pawn in the middle is, yeah, sort of free. But I could use that as an opportunity to get the bishop out. And he can't fork me. He can do that. Let's get this bishop towards the center then. Okay, okay. Yeah, we're packing the heat here. Let's bring the knight out too. If y'all have any suggestions, I would love to hear them. Wow, I can't believe I'm playing at 7:53. I didn't realize my rating was this high on this time control. I'll protect the bishop. Everything's so packed. I'm down a pawn. Oh, it wasn't because of the gambit. I actually took that pawn back. I don't know why I'm down a pawn. I need to remember to look at the board on the screen. So what? His knight could take it, but then I'd take his knight. And then he could take my bishop. So that's the move for him, right? Gets him up a pawn. He's probably not going to do that, though, because that's kind of a wild trade. Did he do it? No, he didn't do it. He forked me. Which I really don't see. Because I just take with the queen, right? Right? What? So I lost that. Yeah. I'm still doing pretty good overall. Do I have anything for that? I can't castle now. I don't really have anything for that. I could attack it. Sorta. Not really, though, actually. Man, I want a castle, but that bishop is there. Does it make sense to move something? Oh, man. I just want to move the knight back and attack the bishop. I just want that bishop out of there so I can castle. Just get that bishop out of here. Alright, alright. Oh, I still can't castle because the bishop is still there. Okay. Well, I could take. Now the bishop's not there. But I guess he could come in with his queen, and that would cause the same issues. Yeah. Yeah. Okay. Also, my rook is being attacked. So what if I did that? That blocks my rook. And then... Yeah, it blocks my rook from being attacked is what it does. And then I could look at bringing my rook over. But I'm still not castling in that situation, which is tough. I could come out and attack the queen and then aim for the fork on c5. That's interesting. So I just lost the bishop. Do I need to just take the bishop back? Yeah, especially because he just prevents everything with the knight that I just said. So let's take the bishop back. We're not up in material. We're down 1 in material. And now he castled. So... Can I do that? No. Oh, wait, yeah. No, I'm decently protected there. Because I got the queen and the rook. So that's not bad. So he's got to move the queen now. And I can at least go take that pawn. Although that's not super useful. So he puts me in check. Oh, if I trade, I still can't castle. He's not going to mate me over here, is he? No, because my queen's there. My queen's still doing work. So I could go in and attack him with the knight. And then probably come right back out. Okay. So... How about... Oh, shoot. Yeah, that would be deadly. Do I need to just sack it? I guess I do. Yeah. That's unfortunate. So let's check them. So what are we down by now? We're only down by 4. Which isn't horrible. So let's come back. I gotta get my other rook out. So I did at least manage to take one of his rooks, so that was pretty good. I'm close to just hightailing that pawn down there. Just that A pawn straight down the line. Well, I can take that as an opportunity to move my king up. If he attacks with my knight, I can take... Attacks with his knight, I can take with the pawn. So he can't do that. He's got plenty of ways to put me into check. That ain't one of them. Push this to protect the knight. There's no forks there, right? I can attack the queen but be attacked by the pawn, so that's no good. The pawn's protected by the rook. That protects the knight. Now I'm back into check. Still not sure what the idea is there. Didn't want to have to go back down, but I shouldn't die going back down. I should be okay. I guess the only scary thing is getting that pawn by his pawn. So I sort of got to think how I'm going to do that. Oh wow. Not like that, that's for sure. Oh. I'm going to push it. Why didn't I like that before? Oh, because I still can't get past that pawn. And now that. Yeah, well now I could move it, right? Or I still don't have anywhere good to move it is the problem. But I could back it up. Oh, I can't because I'm in jack. Alright. Well, that's the opportunity to bring my rook out. So pop the rook there. And then see what we can do. Barrel down into that pawn. Would that work? Well, we're safe to go here for now. If he pushes the pawn, we just push right by the pawn. So I won't even hate that. And then he won't have time to prepare. I'll have time to get my rook over there. Okay. He put me in check. Alright, I'm done. That's a GG. I'll resign. That was tough. That was tough. Ugh. Alright. Let's go back to some math. That's what we're here for anyway. So we've done 3 problems. We're going to do 3 more. We did the combined inequality. We got another combined inequality. So these are nice because they're simple. Alright, let's go. So we got another inequality to solve. I think we just have so many examples just to point out all the differences, but then also just to point out that they're all kind of the same. We got a couple little twists here, though. So for one, we need to get rid of that divide by 2. So let's start off by multiplying everything by 2. So multiply this side by 2, multiply this side by 2, multiply this side by 2. So we'll have negative 2 is less than or equal to 3 minus 5x, which is less than or equal to 18. And then we're going to need to subtract the 3 from everything. So we got that negative 5x is in between negative 5 and 15. And then what's the last thing? We got to divide by a negative 5. But you got to remember what happens when you divide by a negative. We're going to, because look what we got. We got 1, and then x, and then negative 3. So see how it went from the small number on the left to now the small numbers on the right? So that just means that's why we have to flip the sign over. All of these signs are flipping. And then so in reality, we should flip it back around to be how we're used to it, with the small number on the left and the big number on the right. And there we go. That's all there is to it. pop it into interval notation because that's normally how you want your answers. And there you go. See how it works just like an equation. You just do everything to every side. The only difference is that when you're multiplying or dividing by a negative, you've got to flip the sign around. Okay. 2 more. That's going to be... These are so quick. I don't know why I find it so difficult to sit down and make these. Ugh. All right. How even do you solve this inequality? Well, okay, we're going to write it as a fraction. Yeah, okay, I see. We need to take a screenshot. So how do you solve this inequality? Well, first off, realize that the negative exponent means that we have a fraction. So what we really have here is 1 over 4x minus 1 is greater than 0. And then, now what? So we need a fraction to be greater than 0. We need a fraction to be positive. And look how the top of that fraction is positive. So think if you need a fraction to be positive, and we know the one part of the fraction is positive, doesn't the other part of the fraction also have to be positive? And that's how I would go about solving this, is you just kind of got to think, if you need a fraction to be positive or negative, think about what things have to be. Like if this needed to be negative, we would need the bottom to be negative. But we want it to be positive. So we just need 4x minus 1 to be greater than 0. So we just need x to be greater than 1/4. Add 1 divided by 4. And then what's our interval notation? From 1/4 up to infinity. That's an ugly 1/4, but I'm going to leave it. All right, good stuff, good stuff. So we have one more on the schedule. Well, let's do one extra, just so that we're done with the section. Okay. How do we solve a problem like this? If x is in between -1 and 4, find a and b so that 2x plus 1 is in between a and b. So I kind of think about a comparison thing. I see that thing we have on the left, and I'm like, well, how can I make that x in the middle into 2x plus 1? Well, first off, you have to multiply everything by 2 to get the 2x. So we know that multiply everything by 2. So -2 is less than 2x, which is less than 8. And then we got to add 1 to everything. So -1 is less than 2x plus 1, which is less than 9. And then with your comparison, wow, we can see what a and b have to be. A is -1 and b has to be 9. So this is how I like to think about these. You just set up the original, and you got to manipulate the original until it turns into what you want. And that'll let you find what you need. Do we screenshot this? I don't remember. That was a scuffed text select and move around. Alright, so we're going to be done. We've already done our 6, so this is extra. How do we feel about that? Doing extra? When was the last time you did extra? Alright, let's take a screenshot and let's solve it. So how do we solve this problem? This problem is actually part book, so let's take some time to read it. In electricity, Ohm's law states that E equals I times R, where E is the voltage in volts, I is the current in amperes, and R is the resistance in ohms. An air conditioning unit is rated at a resistance of 10 ohms. If the voltage varies from 110 to 120 inclusive, what corresponding range of voltage will the air conditioner draw? Okay, so they tell us what the voltage is. They tell us it's in between 110 and 120. And what they mean by inclusive is that it means that it can be equal to 110 or 120. So I'd go, okay, what's the voltage? The voltage is E. So they're telling me right now that E is in between 120 and 110. So let's see what else we got. So we got current and we got resistance. So we know that that's the E, and we know the air conditioning is rated at 10 ohms resistance. So we know that R is 10. But what are you even going to do before that? I want to substitute this IR for the E, because E is equal to IR. So this is really that IR is between 110 and 120. And what did they just tell us? They just told us that the R is 10. So 10I is in between 120 and 110. Well, now we just got to divide everything by 10, count off these zeros. We see that I has to be between 11 and 12. So the current that will be drawn is in between 11 and 12, because that's what the I is. The I is the current. We found that it had to be in between 11 and 12. Yes. So see how they told us what the E was, the range the E was. We could kind of do this substitution and then plug in the 10, plug in the actual value they gave us, and then find our range of solutions that works for that. So like with all of these sections, you really got to go to the textbook and you really got to practice these problems if you really want to get it down. But next, we will be on to Chapter 1, Section 6. All right. I think that's it for tonight, y'all. It was a pleasure hanging with you for the 27 minutes we were here.